to our conference talk, Pentesting Cloud Sandboxes in the Wild for BSMaaS Munich 2020 in August. We will present our content, and before we start, we'll introduce ourselves. First of all, who we are. Matthias, introduce yourself, please.
Yes, hello everyone. My name is Matthias. I work as a platform security engineer at Salesforce, taking care of our platform as a service offerings. Very happy that we can do this talk together. We're actually sitting next to each other, even though we live quite a bit away from each other. So yeah, very excited. Dealing with cloud containers almost full time for the last 4 years now. Still love the topic, and I'm very excited for the talk.
Yeah, thanks, Matthias. My name is Jan. I'm a kind of IT security specialist, and I love to play around with containers and orchestration solutions. And nowadays, I'm working as a freelancer. Did work in this area and in security area the last few years as a consultant, as a penetration tester, and whatnot. Yeah, okay. So, enough to us. Let's have a start with the content. We will start with a short recap. Last year, you heard from Andreas Krebs on BSMaaS Munich 2019, a talk about containers. He introduced you to what's about containers, how do they work, the history, what's Docker, what's the Docker engine, and how are these container images composed, how does it build up, and so on. In general, we have a container, and you can see it on the right-hand side. A container is building up on a legitimate host system. How does it exactly work? We will have an idea.
Also, 1 second, if you're not super familiar with containers yet, we would recommend that you look at this talk and watch this talk from last year, because it's a really good container introduction. So if you're not familiar with the container basics, we will not cover those. So before watching this, go ahead and watch the talk from last year.
Thanks, Matthias, for the hint on this situation. Just to get a short recap, what we are focusing on. So first of all, Linux containers are just a group of processes, and they are bound together based on Linux kernel features. What exactly kind of kernel features? We have in background Linux namespaces that are used for isolation, like user namespaces, networking, file system, whatnot. And what else kernel features are used? In special case of Docker, they use C groups to limit the resource of the system, and even the capabilities are reduced. And we even have introduced some seccomp filters. So you have not all access to the kernel. They are limited by dropped capabilities and filtering and so on. What kind of container environments do we have? Actually, we have the run C system containerization tool. LXC is the old one. Maybe the old guys from the hood know. Nowadays we have like systemd or Docker or even Firecracker, to name some new one. Actually, you can have multiple containers running on the same host. Well, it's just a group of processes that stick together and bound together. And normally, in terms of containers, you never have a virtual machine, but in some special edge cases, you have some lightweight virtual machines like Kato containers or Firecracker, where we have a microkernel started as virtual machines. But we will come to this in a later situation.
What I always find super interesting is that the term container is absolutely not defined. It's very often the case with any industry-driven, I don't want to say standard, because that implies that there is some definition or standardization, but it's not the case for containers. So with all those container runtime environments like lightweight VMs or down here on the left, run C, LXC, Docker, and so on, so you basically need to just look at the code, what they are doing, and that's what a container is. There is some degree of standardization coming in with OCI, the Open Container Initiative, so that's pretty much the most standardization that we have, but it's still rather new and has not arrived everywhere yet.
Okay, get back to the talk. What we will cover this time. We will discuss at first some container breakout techniques that are possible and what you can perform on normal containers, and the general attack surface of containers. That's maybe an interesting topic, but to be honest, it's almost kind of a misconfiguration issue. And when you talk about your container security situation, it's normally not all of it. The relevant risks are coming with the control plane, management of the control plane, the API, supporting services that are used to build up containers, or even your supply chain. These are the real hard and tough things to cover. But before you can solve these issues, you must get an idea for the basic stuff like container security. In terms of attack vectors on the host file system, from the container perspective, we can share only just directories with the container or even the whole root directory of the host. But if you start a container with an insecure configuration, you may have shared the whole root host directory. And if you have access to the directory from a container, you're still root on the host file system. To escalate from a container to the underlying host, you can use in this situation, just normal Linux privilege escalation techniques. For example, you create a new user and connect by SSH, deploy a new key, or even create a new cron job and wait for a reverse shell connection, something like this. There's something what you can perform in this situation. Another big thing everybody's talking about, and you may have here, is just the attack vector by privileged containers. If you start researching and looking for some details about privileged container and container security, there's always the hint, never start your container privileged. You say, well, what does it exactly mean? A privileged container gives you direct access to the Linux kernel from the underlying host and to the hardware of the host system. What do you actually have? The security measurements that were introduced by Docker to have somehow a separation between the container and the host kernel is by only a limited access for the sys file system. This is a file system for the Linux kernel where you can access it directly. And normally the capabilities are dropped, and in terms of a privileged container, you have access to serious capabilities like a sysadmin or a sys module for loading kernel modules or something like this, or even access to the host devices. What could probably go wrong? You can, if you have access to the devices, you can just go and mount the volumes like the hard drive into the container and modify it. So it's like similar to the previous attack case. Or even just from one of the last blog posts that was published with like access to the proc keys, where you have the kernel key ring access to and read out the details out of the key ring. But in this case, I would recommend you to dig into the blog post. It's amazing. What kind of attack vectors do we else have? Actually, we have in some cases that you start your container with a mounted Docker socket. The Docker socket, why do you actually need the Docker socket in the container? The Docker socket is the control plane to control your containers on the local system. And if the control plane is mounted into a container, for sure what you can do is just use the control plane and start a new container. And these containers can be started in any flavor you like. For example, you make a superpower container, which is privileged. You have access to the host network. You can directly interact with other processors by IPC and even modify the host namespace. And if you the last step to get out of the box is switching the mount namespace, which you can use as the system command nsenter, and then you are with nsenter -t1 and -m, then you are in the mount namespace of the host of the init process, and then you actually are owning the system. That's also an attack vector. So, since we are talking about the cloud, the previous attack vectors were more likely to be for local systems, if you have a local Docker container that started. But if we are in a cloud environment, what actually is the dangerous part? We have the cloud interfaces. The most interesting one, and if you're looking into bug bounty, for example, there's always an edge case and everybody's talking about server-side request forgery. Though you have access to the metadata API, it's the control plane of the cloud. And just having a container start and stop in is just one point. But if you decide to go into the cloud with your containers, you normally leverage features from the cloud. What exactly does it mean? You have service accounts for the metadata API, just access tokens for this metadata API. And from there, you can control the workloads. You may have access to the storage that you have configured, like an S3 storage or something like this. Or in worst case, you can even go and can take over the cloud account. Depends on the configuration of the access tokens. We have compared common cloud platform provider that are out there. To name a few, to name them, we have AWS from Amazon, Azure from Microsoft, just local Docker. A new cat from the blog is the Fly.io, and even GCP and Heroku as container providers. To get an idea from the comparison, in the default case, you have in case of AWS ECS, the metadata API. In this part, we have a remark that you have a custom cluster that has to be started exclusively for us. In AWS Fargate, in comparison, you have a shared host. So you can see it based on the seccomp filter, for example, that there's a separation. Furthermore, in case of Fly.io, we have what I've told you beforehand, a micro light VM virtual machines like firecrackers, so you don't have actually not access to the Linux kernel, the underlying kernel. There is an abstraction layer for the kernel by the firecracker. In case of Google Cloud Run, we have the gvisor, or in Heroku, they use under the hood LXC. And so from this derived, we have different measurements. A detailed comparison is on the GitHub site that's linked below the image. And there you can find all the different capabilities and seccomp filters that are introduced. Okay, the summary of the attack vectors. Matthias.
So Jan was giving us an overview of the different attack vectors. So basically I would summarize them into mounts from the host system, which opens up possibilities for all the different traditional Linux local attack vectors. We can have privileges assigned to a container. It can be either fully privileged, you can have some capabilities, some system calls might not be filtered, or access to certain unnamespaced entities, components might not be available, like for devices. Then you may have sockets mounted. The most prominent example is the Docker socket, and you have control plane access. By that we mean, for example, access to the cloud metadata API, but it can also be other control planes, as we will see in a moment. So, if you want to perform an attack surface analysis or pen test cloud sandboxes, container environments in the wild, as the title of our talk suggests, there are actually two amazing tools already out there. There is Bob with a Silent Team by Chris Leroy. Link is here on the slide. And then there's Am I Contained by Jess Frazell. Both of those cover slightly different aspects of those breakout vectors, and we will go through them right now. Also, I have a backlog of things that I want to add to the tools. Jan already had some pull requests merged into them, so we are really big fans of those tools. So if you want to automatically analyze those attack vectors, first we will have a look at Bob. One of Chris's hobbies is looking for Linux sockets and find fun things that you can do with them. So there's a lot of options available for that. So there's also an autopone option, which is basically it moves your own container into the host namespace with like everything namespaced in the host. So basically your current process is running as a regular Linux host process now. This is abusing like an exposed Docker socket, and the autopone option basically just does what you usually want to do, get a privileged environment. You can, however, also look for domain sockets that are available. As I said, the Docker socket is just the most prominent example, but there might also be other sockets available. We've seen cloud environments where the hosting provider exposes services into the container, for example, logging services or also control plane services via Linux domain sockets. And since this is usually local, they often don't worry about authentication or something like that. So we also have an option to like hunt for any type of sockets that might be available in the container, and chances are that those are quite interesting actually. Then there's two control plane options in Bob. So it's extracting mounted Kubernetes secrets if there are any available, and it is also parsing for metadata access to cloud services. This is the contribution that Jan actually made to the tool.
Yeah, right.
So this is what Bob does. There's also some other like fancy features in there. For example, there's like a CI pipeline use if you have a build environment that needs this type of analysis. There's a CI mode involved. You can also like upload the scanning results to an S3 bucket and such. And yeah. Then we have MI contained. MI contained gives you an enumeration of the other privileges that your container might have. It is also checking for the Docker socket, as we see at the very bottom, but this is only like the standard location of the Docker socket. If you want to perform like a more comprehensive search for any Docker sockets that are available, you want to use Bob. What MI contained gives you is a good analysis of the enabled privilege separation features going from top to bottom, basically whether namespaces are available, and it's here checking for the PID namespace and the user namespace. So we see user namespaces are not being used here. This container is also not running with an AppArmor profile assigned. We have certain capabilities that are limited, and we have certain system calls that are blocked. So the interesting part is, if you would want to do this manually, you could via /proc/PID/status actually identify whether you have seccomp filtering enabled for your process. However, it only tells you is it enabled or is it not enabled. If you want to know which system calls are blocked, you just actually need to try and perform all system calls and look for the return code that you are getting. This is actually quite interesting, since on the Heroku platform we often got bug bounty submissions that say, oh, you're not doing system call filtering, but certain tools are only looking for certain error codes, and we return a non-custom error code for our filter system calls. So be careful when you perform this analysis there. So these are the tools that are available for automatically assessing your container environment, and I think this is also what Jan used for creating the overview of those environments. So also, what can you do about that? If you want to ensure that your containers are properly hardened from the runtime perspective, we will come back to that, but as we said, this is only one aspect, and I often refer to this as container runtime security. So if you want to harden your environment and you want to mitigate all those potential problems, what you have to do depends heavily on your runtime. If you use a public platform as a service runtime environment, there's usually not that much that you can do. They basically won't allow you insecure configurations with regard to breakout techniques. I mean, that's in their best interest to maintain isolation. Otherwise, they could not offer a multi-tenant platform. So if you want to definitely host your own environment, which may be required by some security policy or some consideration or whatever. You have to harden your own runtime, obviously. So there's basically two options that I see. You can build your own abstraction layer for deploying workloads. So you basically offer like a small web service where you can submit workloads to, and then you basically build your own runtime container yourself with the own runtime configurations that you choose, and the abstraction layer that you have basically just allows for submitting a Docker image, but how this Docker image is started and how the runtime is configured is completely up to you as the infrastructure provider. If that is not an option for you for some reason, you can still basically analyze the deployment artifacts that are being submitted to you. And there are already several tools out there. When it comes to Dockerfile, there are actually 2 linters out there that gives you very good results when it comes to security or best practices in general, but also security best practices for Docker files. For example, don't run as root, don't use add with or don't use add at all if you can avoid it. So there's two options available for Docker files. For Docker Compose files, we're not aware of any tools that do that. However, I also don't think Docker Compose is super relevant anymore at the moment. Personally, I like Docker Swarm a lot, but everybody else has jumped on the Kubernetes bandwagon. So for Kubernetes, there's actually many options available how you can harden your runtime environment. This is only like a selection of tools that I like the best. So the top one is MKit, the Managed Kubernetes Inspection Toolkit, that does not only analyze your running containers, but also your cluster configuration. There is Styra, which is a paid service by the Open Policy Agent founders, I think, or at least some early developers, that basically now offer you managed Open Policy Agent configurations for your Kubernetes cluster for all types of things. Something very similar is K-Rail. It's a very similar concept that also hardens your cluster and also continuously monitors it. It's also a very good tool, and then a more of a audit-based tool is KubeScore. However, when it comes to hardening your runtime environment, it's actually also not that hard to harden your Kubernetes cluster yourself. Kubernetes clusters have something that is called admission controllers, and you can basically integrate pod security policies and OPA. They have a big overlap in what they can do, but some things can only be done with OPA, for example. So you determine the hardening that you want to perform, and then there's actually good guidance available how you want to design your pod security policies and how you can actually tie that into an admission controller. So admission controller is a feature of Kubernetes that, as the name says, controls what is getting admitted to the cluster. So any deployment is pushed through a chain of admission controller hooks. So you can also write your own admission controller and just hook into that chain and then basically give a yay or nay upon deployment. However, all those admission controller or any webhook controller in Kubernetes clusters are very, so basically they are blocking. If you want to deploy anything and one of the controllers that are being configured fails, nothing works anymore. You can't configure your cluster or can't make any changes. The running workloads, they just work fine, but any changes that you want to do, they need to go through the admission controller chain. So if one of those fails in there, anything's going wrong, you have to troubleshoot and debug your cluster. So they are a little bit of a double-edged sword. They are cool things that you can do with them, but at the same time, they are also mission critical because they can be blocking changes to your cluster. So, summing this stuff up, containers are an amazing thing from an engineering perspective. We're both huge fans, and I think we use Docker containers for lots of daily tasks.
Almost everything.
Yeah, right. And you can definitely operate them securely. As I said, I'm working for a big platform as a service provider whose isolation is mainly based on containers, and we did not have to release any press release about failed multi-tenancy issues yet. So you can definitely harden your container properly and also enforce proper tenant isolation with them. You don't want to misconfigure anything. Actually, also many containers come in quite, or many container runtimes come in quite a secure default configuration. I have to admit, Kubernetes had some ugly outliers in the past, where basically, if you wanted to run a pod as a non-root user, you could configure that, but Kubernetes was not doing that. I think seccomp filters are by default are also just finally coming to Kubernetes. So
you can import them by pod security policies.
you can do that, but the default deployment does not leverage those. So with Kubernetes, you definitely want to pay some attention to your hardening, but if you have a default Docker runtime, the state is actually not too bad. Yeah, and then it completely depends. Obviously, I'm a big fan of platform as a service providers that offer you container services, but what you select in the end might heavily depend on your company policy or which golf court your company execs are going to. So have a look at your cloud platform provider. You have now some tools to analyze what they are offering you from the security perspective, and this should enable you to properly harden your own environment wherever it is running. Some further tasks that we have on our mind, some tooling that we want to do, so for example, a cloud metadata scraper for all the big cloud platform that basically just dumps all the metadata content, is something that's not available from my perspective yet. The one project that I want to do since a long while is a container privilege footprinting, where you basically run a container and monitor which system calls and capabilities and such it is using, so you can actually minimize the available privileges to it. We also want to extend Bob to scan for binaries with assigned privileges. So those privileges, the capabilities that we talked about earlier, they can also be assigned to binaries, not only to users, but also to binaries. So this is a very interesting thing.
And a good way to backdoor a system.
Absolutely, yeah. And then personally, I also want to extend the MI contained documentation. So you can actually also read about what MI contained does, what the impact is, and make it a little bit of like container privilege knowledge base. You can always read the code, but we all know that can also be tedious at times. And now, thanks for your attention, and we're more than happy to take your questions in any form.
Yeah, thanks for your audience.
While you gather your questions, here are some references that we have in here, and also shout out again to Chris and Jess for their amazing work with Bob and MI Contained.